Okay, welcome 30-2. So now we're going to get to something called combinations. So we've been doing permutations in the last lesson, and now we're going to do combinations. So it's similar, but it's going to be a new idea. So to get our bearings here, let's read through this example. So it says, a charity benefit is attended by 25 people, okay, at which three $50 gift certificates are given away as door prizes. Assuming no one person receives more than one prize, how many different ways can the gift certificates be awarded? Okay, so first off, the fact that it was a $50 gift certificate, I know that's a number, but that wasn't really relevant. It's really just that there's 25 people and three of them are getting something, right? Okay, so using the basic, our fundamental accounting principle or our basic accounting principle, there are 25 people to choose from. So for the first person, so after the first person, there'd be 24, yada yada. So kind of what we've been doing before, right? So if we were to pick this, just draw our blanks, and we could say, okay, first spot would be 25, and then 24, and then 23, and you multiply, and then that would be the number of ways that that could happen, right? And that would be 13,800. Okay, but if we think about it though, that's one way that could happen. So suppose if we put actual names to this, that this would be the situation that, like, let's say Abe is chosen first, and Bay is chosen second, and Cindy is chosen third. Okay, so this is one of the 13,800 possibilities. Another way to award the prizes would be to choose Abe first again. Oh. Cindy second, right? So instead of Bay second, we could choose Cindy second and Bay third, right? This is another of the 13,000 possible outcomes. But either way, these three people, right, each get $50. Okay, so the way we were doing it, it's like this was like our first spot, right? Then after we've chosen that, we chose this one. Then after we've chosen that, we chose this one. But what if we were just interested in, like, what's the how many ways can these three people in general receive a $50 gift certificate? Because it doesn't really matter who was the first one to get it, who was the second, who was the third. We just want to know, did they get one, right? How many ways can these three people do this? So if you think about it, if we just like wrote these out, right? So this A stands for Abe, Bay, and Cindy, right? Abe, Bay, and Cindy. Then you could arrange those 6 different ways, right? In different ways, like one could be first, one could be second, one could be third. So if we think about it, another way of writing that would be, well, we can think about it this way, where if I'm just focusing on to know whether or not I got all of these different orders here, then that'd be the same thing as doing this. We'd have 3 spots, and we're just choosing 3 people, right? So it's like 3 times 2 times 1. This is really like just a factorial or a permutation from before, right? So we can say that there are 6 different ways that we can arrange those guys. If that's kind of confusing, it's all right. We'll kind of get. I'm just kind of like getting to the chase here, like why this is going to matter. So in the end, though, let's just for a second, if this confused you, just look at that. We had 6 different possibilities here for those people to be rearranged. Well, if you think about it, if our question really was just how many ways can these 3 people get a $50 gift certificate, then we were 6 times too big before, right? Because there's these 6 different possibilities. So really what we got to do is we got to go 13,800 divided by 6. And then that would tell you how many ways just the 3 of them could receive a gift certificate. The order doesn't matter. And that's going to be important when we get into combinations here, right? And when I mean the order doesn't matter is that there's not like a picking someone first, picking someone second, picking someone third. It's just that how many ways can like the 3 of them finish first, second, or third. I don't care who was first, second, or third. Okay, but I'll do some examples below, I think, and I think that'll make that more clear. Okay, so another way of writing that, you could say that this is the same thing as, well, and here's our new, well, kind of formula. We're going to use the one more below in 30-2, but NCR, so combination, right? So this before, this is like the number that we start with, and then this is like the number that we choose again for our R, is going to be equal to NPR, like stuff we did above, but then dividing out all of the, it's kind of like dividing out all the repeats, but it's dividing out all of these like 6 cases in like in this situation, right, where we don't care about the order. We're like dividing out all the places that we don't care about the order. Okay? All right, so we say that there are NCR combinations of size R that may be selected from among n choices without replacement, where order doesn't matter. And that's going to be the key for these ones. Order doesn't matter. Okay? Another way of writing this is just like this one. So here, let's for a second though, I just want to throw a number in for that one. So if we had like NCR is equal to n factorial over n minus r factorial times r factorial. And let's say the question was something like, if there were 9 people, and we wanted to choose 3 of them for a committee or a group or something, then it would just be 9C3. And why I said group, because of the 9 people, we're choosing 3 to go in some group, because that a group means that there's not like a first place, second place, third place or anything. They're just in a group. I don't care what order they're in that group. Okay, so if I did that, I just want to show you like the pattern, what happens here. So 9C3 is going to be, well, okay, so our n was 9, so that'd be 9 factorial over, and then 9 minus 3 factorial. Okay, well, and so far, if you remember, that was just a permutation, wasn't it? That was like our equation from last time. Okay, and then after that, we've just got 3 factorial. All right, so from that, let's just write this out again. So this would be 9 factorial over 9 minus 3 is 6 factorial, and then 3 factorial. This will actually always be the pattern with combinations. Do you see how these 2 bottom numbers add up to the top number? That doesn't mean that they're all going to cancel, right? It's not like this is 9 over 6 times 3, right? Or I guess that wouldn't cancel either, but these are factorials. So this top number is actually quite a lot larger, because this is like 9 times 8 times, you know, so 9 being up there, it makes that a lot larger than the numbers in the bottom. But anyway, this will always be the case, that those 2 in the bottom will add up to the 1 on the top. So you can always write it that way too, right? Okay. NCR is so popular in math that it's often just written like this. So instead of NCR, we'll quite often just write NR in like brackets like that, without like a division. There's no like division sign in there. Just N over R, or NR, like that. But it means the same thing. Okay. All right, let's look at this one quick. So a student, or a group of 4 students is chosen from a 35 member class to represent the class on student council. How many ways can this be done? Okay, so we've got 35 students, and we're selecting them for student council. So if they're on student council, there's not like it's not like a race situation like in the last lesson, where it was like, how many ways can someone finish first, second, and third or something, right? It's just they're on a council. I don't care who's first in the council, second in the council, or third in the council, right? They're just on the council. So what we're doing is we're going to divide out all the different ways that the order could just be rearranged for the members of those council. Okay? And then really, we're just putting it in our calculator quite often too, to tell you the truth. But so we just start off with 35, and then we are going to choose, so C, 4. So it's kind of similar with before, right? Where I said it would have been like 35, pick 4. You can think of like 35, choose 4. So of the 35, we're choosing 4 for our committee. Okay, at this point, you could go to your calculator and you could just plug it in, because you have like under probability, same places with permutations. You'll see there's a combinations one as well. If we're writing this out though, then this is the same thing as, well, let's write out our actual equation. So 35 C4, oh here, I'll write out the equation again. So our equation is NCR is equal to n factorial over n minus r factorial times r factorial. Okay, so that's equal to, so 35c4 would be 35 factorial over 35 minus 4 factorial times r factorial, or times 4 factorial. Okay, now let's just change this up again. So we got 35 factorial over 35 minus 4 is 31 factorial, and then 4 factorial. Now see what happened here, right? If I just look at this, just this part for a second. Well, 35 factorial over 31 factorial, if I just write this out a little bit more, that's like 35 times 34, I'm not going to do the whole thing, times 33 times 32 times 31 times 30 times 29. I'll stop there. And then it's like dot, 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 and it'll go all the way down to 3 times 2 times 1, right? But I just want you to kind of see that this 31 here, well, that would be like, well, 31 times 30 times 29 dot, 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 3 times 2 times 1. Do you see that like all of these ones canceled on the top there? We didn't have to write that whole thing out. You can kind of imagine that this 31 just canceled a whole bunch of this 35 here, right? It canceled all of that. So on the top, all we really had was this 35 times 34 times 33 times 32. And on the bottom, we've still got 4 factorial. So 4 times 3 times 2 times 1. And remember that the bottom here, this is just all the ways that those 4 people on the committee could be rearranged, right? Because I don't care who's first, second, third, or fourth or whatever, right? So that's just 4 factorial for the number of ways it can be rearranged. Okay, so then that would be our, so if you put that all in, we get 52,360. Okay? All right. Try it now for. So it says the United States Senate Appropriations Committee consists of 29 members. The Defense Subcommittee of the Appropriations Committee consists of 19 members. Disregarding party affiliation or any special seats on the subcommittee, how many different 19-member subcommittees may be chosen from among the 29 senators on the Appropriations Committee? Okay, really what we got going on here is this is just going to be 29. So of the 29 Appropriations Committee members, we're going to choose 19 for our subcommittee. And that's it. We could also write that as 29, and then it's like over 19 with brackets. So same thing, you'll see them written both those ways. And then if you plug that in, we get a big number. So lots of different ways that we could make these groups for these committees. All right, now let's move on a little bit. Okay, let's do a couple other questions that are on your homework. So if you want to, it'd probably be good to get a piece of paper. You probably don't have room on your notes here, but if you can pause it and then go get a piece of paper, because you're going to get this question, so we get to see how it's done here. So this one says triangles can be formed in an octagon by connecting any 3 of its vertices. Determine the number of different triangles that can be formed in an octagon. Okay, so let's draw an octagon. Okay, there's my octagon. So if you want to take a second, pause it and draw yours too. I put little green dots there to kind of show the vertices a bit better, just because my octagon wasn't so great. But okay, so what the question's saying here is how many triangles can be formed out of this, right? So if you think about a triangle, so let's just make one of them to kind of see what we're talking about here. There, like that would be a triangle, right? Or this could be a triangle from like there to there to there, and they want, so that was 2, right? We made 2 triangles out of that, and they want to know how many different possibilities are there. Okay, so here's the idea here is that when I'm looking at this triangle, like let's say the one I just drew here, like that one from there to there to there, Does it matter which corner of the triangle is first, second, or third? Well, no, right? It's just a triangle. You have to have all three of those points to make our triangle, and the order doesn't matter. So that would be the first sign for me that this is a combination question and not a permutation question. Okay? So I'm just gonna figure out what my total is to start with, right? So of the different, well, there's 8, right? There's 8 different vertices in total that you could choose from, right? So in total, I've got 8, and then I'm just gonna choose 3 of them, right? 8 choose 3, and it doesn't matter on the order. So that's really it, just 8 choose 3. So it's not too bad once you kind of figure out what they're asking for in this one. So let's write it out to do some practice with this. So our actual equation would be 8 factorial over 8 minus 3 factorial times 3 factorial. That's just using the formula on your formula sheet there, right? Okay, so this is the same thing as 8 factorial over 5 factorial times 3 factorial. Again, notice that 5 and 3 will always add up to give you that top number when you're doing these ones. Okay, I'm going to write it out. So this would be the same thing as 8 times 7 times 6 times 5. 2 and 1. And on the bottom, I've got 5 times 4 times 2 times 1. Okay, so that's that part. And then 3 times 2 times 1. All right, so I'm going to cancel all of the 5 down with all of that. And then here, I'll write it again to get clean this up. So then we've got 8 times 7 times 6 over 3 times 2. Okay, well, the 6 here and the 3 times 2, like 3 times 2 is 6. So I'm going to cancel the 6 with the 3 times 2. So 8 times 7 is all that came down to. So this is just 56. All right, now one more, and then we'll be done here. So it says, in a group of 7 students, there are 3 females and 4 males. So this is a very standard question that you guys are going to get. So first off, it says, how many different 6-member committees? All right, so that's drawing my attention to the fact that the order doesn't matter in a committee, right? It's like just a group of people. There's no first, second, or third, right? How many 6-member committees are possible if there are no restrictions? Okay, so what that means is that, okay, if we've got 7 students, so I've got 7 to choose from, then I'm going to choose 6, right? And what it means by no restrictions is because down here in a second, we're going to restrict it to it has to be a certain number of girls, or it can't have a certain number of boys or something like that, right? So with no restrictions, it just means of the 7 people, I don't care who's female and who's male, we're just going to choose 6. So that's just the standard question, and this 3 and the 4 just didn't matter. We weren't splitting it up by females and males. So that would just be 7 choose 6. Or, here, I'll write it like this too, just so we get used to it. 7, 6 is equal to, okay, and then I'll just put in my calculator for this one. Well, actually, that'd be kind of silly. Let's write this one out. So that would be the same thing as 7 factorial over 7 minus 6 factorial times 6 factorial. Okay, well, 7 factorial over 7 minus 6 is just 1 factorial, and then 6 factorial. Okay, well, 1 factorial is just 1, so that didn't even really matter there, right? So that can be gone. And then 7 factorial over 6 factorial, maybe you can do this one in your head. That one would just be 7, right? If you wrote that all out, if you had well, I'll let you do it. If you expanded 7 all the way down to 1 and then 6 all the way down to 1 and then canceled, you just have 7. Okay, so there's 7 ways that can happen. How many different 6-member committees are possible? And then here's the new thing. If there must be exactly 2 girls. Okay, so let's do this one. So if there has to be exactly 2 girls in our situation, then we're just going to have to split it up. We're going to have to go, okay, of the 3 females, okay, so of the 3 females, we're going to choose exactly 2. We're going to choose 2. Okay? So that would tell you all the ways that you could choose 2 females. But fundamental counting principle, we have to multiply that by the number of ways that we can choose. Here, so that was girls. Yeah, so we have to multiply that by the number of ways that we could have the boys, right? So how many different combinations are there for the boys? And how many boys would be left? Well, of the 4 males, so of the 4 males, we're going to choose, and now here's the question, how many are we going to choose? Well, how many does there have to be on the committee? There's got to be 6, right? We've chosen 2, so this must be 4, right? So of the 4 boys, we got to choose all 4 of those boys in this example. Okay, so then that would be equal to, okay, so if I have 3 girls to choose from, and we're only choosing 2, we're going to have the same type of thing as in the top here, right? So that's going to come out to just 3, right? So that's like saying 3, and then times, and then we can do this one in our head. 4C4, like we could put all in the calculator, but in the end here, what we're going to get is, well, this is kind of saying, of the 4 boys, how many ways can we choose all 4 of them? Well, there's only really one way that can happen. You can choose all 4 of them, right? That's the one way. You can only choose all 4 of them. Doesn't matter in the order. If I'm going to choose all those boys, then there's just one way that can happen. So this is just going to be 3 times 1. So this would just be 3. There's only 3 ways that could happen. Okay, next one. How many different 6-member committees are possible if there must be at least 1 girl? So the word at least is important here. Okay, so the way we have to do at least situations is we have to add up all of the different ways that could happen. So 1 girl. All right, so if there was 1 girl, let's find how many ways that can happen. And then we'd find what would happen if there was 2 girls, 3 girls, 4 girls, 5 girls, and 6 girls, and add them all together. Okay, so we've got to like add up all those situations. So at least 1 girl. So let's figure out the number of ways that, let's figure out the number of ways with at least 1 girl. So first off, it'd be, okay, so of the 3 girls, and I'll do this one the other way so we get used to it again. So of the 3 girls, we're going to choose only 1 of them. Okay, but then I've got to multiply that by the number of boys, right? So then the boys would be, of the 4 boys, we are going to choose, well, what's left? And that's got to be 5, right? It's got to add up to 6 there. Okay, so that right there is the number of ways for 1 girl. But we need to add that to the number of ways that there are 2 girls. Hopefully that makes sense, right? So that we figured out the number of ways of 1 girl. Now we got to do the number of ways for 2 girls. So we'll just keep going here. So we'll say, of the 3 girls, we're going to choose 2. And we're going to multiply that by, well, of the 4 boys, then, well, now it would just be 4, right? Oh, shoot. that last one didn't work there. All right, so, yeah, my bad, guys. Well, nothing, we didn't really do anything wrong there. We would handle it this way, but you guys might have saw this before I did. I just said of the 4 boys, we were choosing 5. Can that happen? No, that can't happen, right? So that example just doesn't happen. So we can just cross that out, right? We'll just ignore that one. So this will really be our first situation. So it says at least 1 girl, but there won't be a girl. So we just won't include that one as well. Okay, so moving on here. So that'd be with 2 girls. And then we will add the number of ways with 3 girls. Okay, so of the 3 girls, we're going to choose 3. And then multiply that by, and then what's left here would be of the 4 boys, we're going to choose 3. Okay, so that would be with 3 girls. Now, remember, there is only 3 girls. So our situation, we would have kept on going, right, if we had more, but that's all we have. So this really will just be our answer here now. We'll just have to add up these 2 situations. Okay, so in this example, this was just 3 choose 2. We've kind of done these ones before where it just ends up, if it's the number on the bottom is just 1 smaller than that one, like in the one above, that just ended up being 3, right? So that's just 3 times 1. 3 times, because 4 choose 4 is just 1. So that's just 3 times 1 plus, and then 3 choose 3 is just 1. Okay, so that's just 1 times, and then 4 choose 3 is just 4. So this is really just 7. So there's just 7 ways that this can happen. This is kind of a funny question because the numbers are so low. They wouldn't be so easy or such small numbers in some of the examples, but okay, so that's pretty much it. So just remember going back here that combinations are, the order doesn't matter, because you might be getting this down where you're like, putting it in your calculator or whatever and getting the right answer out, because some of them weren't too complicated. But next we're going to be getting questions where you don't know if it's a combination or a permutation, and you're going to have to make the best decision on what you think the answer would be there, right? So you're really looking at, does the order matter? So just always keep that in your mind. You're going to be saying that over and over again. Does the order matter? Okay, so see you guys in class.